Hi, everybody. This is Mr. Folly, and welcome to the last podcast of this section. We are going to figure out what intermolecular forces are, and we are going to apply them. So, we talked a little bit about intermolecular forces before, I think. We talked about what types of bonds they have. So, hydrogen bonding has H covalently bonded to N, O, or F. That H is attracted to a lone pair from N, O, or F on a different molecule. This is the strongest of this group, polar bond, but so strong it is special. And I'll give you the Tesla example in class. So if you look at these are called intermolecular forces, which means between. Wow, let me write that where we can actually read the word between. Betwixt, if you prefer. There's a difference between betwixt and between. I forget what it is, though. Here's a molecule of water. Here's another molecule of water. Do you see how this is an intermolecular force because it's between those two? Do you see how H is covalently bonded to O? Hey, there's a covalent bond to O. And do you see how there would be a lone pair on oxygen? That's a hydrogen bond. Okay. See how this is not, because this is an H not bonded to N, O, or F. Right? So on this one, I have N to H, there we go, bonded to the lone pair on another one. N to H, here's my N to H, and there's the lone pair on the N. Okay? All right. So if I have hydrogen bonding, and this is kind of, I threw these pictures are in here, so it kind of loses a little bit of the kick here. If you have hydrogen bonding, you clump the most, okay? You clump the most. That's very, very important for you to do. Hydrogen bonding will clump the most. It is the strongest force. Clump the most, strongest force, okay? Dipole-dipole is for polar molecules. So remember how we had to figure out, is it polar, is it nonpolar, is it polar, is it nonpolar? By the way, up here, these will always be polar. But when you see the H to O, if you look at that, you don't have to think that hard about the other ones. Dipole-dipole, make that polar, not dolar. Dipole-dipole for polar molecules. Polar molecules are attracted to another polar molecule. If you're a polar molecule, you are ended, right? Here's my molecule. Here's the positive end. And what attracts positives? Negatives. There you go. Okay. Dipole-dipole is stronger than dispersion. And when I compare dipoles to other dipoles, first look at En. That's your electronegativity difference, right? This is electronegativity difference. Then check dispersion. We'll get to dispersion in just a second, okay? Dispersion forces are for nonpolar molecules, but everything has dispersion. So dispersion forces for nonpolar molecules, it is all they have. So this is a nonpolar molecule's strongest force. It's weak and it's temporary, but it can build up. Okay? It's based on the size of the electron cloud. Bigger molecules have bigger clouds. 2 electrons will be evenly distributed. So if I do this, and there's my atom, and I have 2 electrons, I'm going to have 1 on each side, right? Now, if I have 1,000 electrons, we're way more likely to have like 502 and 498. You wouldn't be surprised if that's what we saw for a minute. And if we had 502 and 498, for an instant, this is going to be delta negative and this is going to be delta positive. Okay? So remember, electrons are and they're all over the place in constant motion, so that's why it's more polarizable. London dispersion forces, it is a London dispersion force, but we just call them dispersion. We've kind of dropped poor London. He's been forgotten in the time world. So what happens here is this, remember, this is the nucleus, and this by chance, but this is unbalanced. So these two started off being neutral, 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 and then by chance, boom. And then what happened? Okay. So what happens is, and again, let me emphasize the things about dispersion that are on here. They're weak, they're temporary, and they can build up, okay? They are often called induced dipoles. Notice how this was induced to be polar. Okay. Dispersion is a tiebreaker of comparing hydrogen bonds to hydrogen bonds or comparing dipole to other dipoles. Okay. That just means the bigger it is. It's hard to tell when dispersion is greatest, but the clumpier something is, the stronger it is. So let's talk about the things we should know about. If I have stronger forces, you're more likely a solid than a liquid or a gas. Okay? What clumps up more? Solid is the clumpiest. Gases aren't very clumpy. Greatest viscosity. Viscosity is resistance to flow. So think about pouring a ketchup bottle. Oh my goodness, I got to draw a ketchup bottle. That doesn't look like a ketchup bottle, but let's make it a honey jar. Oh, a jar of honey. And out comes the delicious, oh, can I make it yellow? I can't make it yellow. The yellow honey. Doesn't honey flow slower than water? That's because honey clumps more, right? Viscosity is resistance to flow. Slow pour for ketchup, fast pour for gasoline. Ketchup has a greater viscosity and greater forces. Okay? So again, if I'm stronger, I'm more likely a solid. If I'm stronger, I have a greater viscosity, which means I pour slower. If I'm stronger, I evaporate the least. Evaporation means the liquid particles leave as a gas, right? Strong forces keep them together, clump, 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 clump. Evaporative things usually smell. Gases and perfume evaporate easily. They turn into gases. I can smell that. The next thing, if you have a stronger force, you have this more surface tension. Surface tension means you're held together the most. If these are all molecules, if they very much love each other, they will stack up like this. If this one has no love, no attraction, I'm not going to use love, I'm going to say attraction. No attraction or weaker attraction. Do you see how it would fall and go here? Same thing would be here. And what I would be left with would be a bunch of one layer thick. Surface tension means which one holds together the most, has the tallest dome. I talked before about highest melting and boiling point, and that goes back to A. If you have a strong force, you have the highest melting and boiling point. You should know water has very strong forces for its size. Nonpolar molecules have dispersion forces only. Polar molecules have dipole-dipole or H bonding. All molecules have dispersion forces. Tiebreakers. Dipole-dipole's first polarity. Second is size. Bigger is stronger, and that would mean stronger dispersion here. Oops, I used too many parentheses. Bigger is stronger because it's more polarizable, and more polarizable means more dispersion forces. Intermolecular is between molecules, H bond, dipole, dipole, and dispersion. Intramolecular is within molecules like covalent and ionic, metallic, and network covalent. And we don't do anything with network covalent besides ignore it. And that is it. And we're all done with this unit of eternity. And to that, I will say, toodles.